Have you ever wondered how some investors seems to predict the stock market like magic? What if we could harness the power of machine learning to do just that? Hey everyone, welcome back. Today I'm going to show you how I build a machine learning model that helps you predict the stock prices using historical data and news headlines. As an intern at the Spark Foundation, I had the opportunity to work on this project. Stay tuned to see how I built it. In this video, we will explore a project that combines the stock market data and sentiment analysis of news headlines to predict the future stock prices. By the end of this video, you will understand the entire process from data collection to model building. Now let's straight away dive into it. Now first of all, we will need a right data. For stock prices, I have selected the BCE Sensex data. I have collected the data from 2001 to 2024. I have collected this data from Yahoo Finance. Yahoo Finance provides a very well-structured form of data from date, close price, open price, and high and low also. Now for the news headlines data, we have collected this data from Times of News headlines data. This has all the news headlines for the particular dates. Now let's move on to our data processing. Now first of all, we will import all the important libraries that will be required throughout this project. For example, pandas for data pre-processing, NLDK for sentiment analysis, sklearn for model building, and matplotlib for visualization. Now in the next line of the code, we will download the stock words from the NLDK library. Then we will load the data, the news headline data in the data frame. As you can see here, this data frame needs a little bit cleaning. We don't require this headline category. The published date needs to be converted into date type. We will remove all the stock words from the headline text. For cleaning this data, we have created a def function clean text that will remove all the stop words and lower the text and return the clean text into the data frame. Here we will drop the headline category, drop all the duplicates, convert the published date column into a date type column, and we will group the headline text by the date column. In this line of the code, we will clean the headline text data by our def function, and it will return the clean headline into our data frame. Now we will perform the sentiment analysis on our clean headline column. We will use the sentiment intensity analyzer from the NLTK package. We will use the VADER for sentiment analysis. This line of code will provide us the polarity score like compound, positive, negative, neutral, and this all will save in the news data frame. As you can see here, we have loaded the news data frame. We have all the sentiment. This sentiment is the compound, the sentiment positive, the sentiment neutral, and the sentiment negative. This gives the score which helps us to find the sentiment score of the clean headline data. Now moving on, we will load the stock data into our data frame. As you can see here, we have date, open, high, low, close, volume. We don't need this adjust close, so we will remove this and clean our data. Now for analysis of our stock data, we have created some def functions to calculate the RSI. RSI is relative strength index. Then OBV, the open balance volume for the volume column. Then we have calculated the simple moving average, exponential moving average, also calculated the MACD. All of this will help us to analyze our stock market data. Now moving on, here we will drop the adjust close column as we don't need it. We will convert the date column into a date type. Then we will remove unnecessary things. Then we will call the calculate technical indicator function that will return all the required things into our stock data frame. As you can see here, we have all the values in our data frame. Now after cleaning the data, we will merge the sentiment score with the stock data to create a comprehensive data set that will have all the numerical and textual features. As you can see here, we will merge the data by the date column. After merging both of the data frames, we get a new data frame which contains sentiment scores from the news headlines and numerical values from the stock data frame. As you can see here, we have all the values in a single merged data frame. Now moving on, we are going to remove headline text and clean headline as we don't need it anymore. Now taking this new data frame, we are going to perform our prediction model. For our prediction model, we have created another def function, that is rolling window forecast. This function performs rolling window forecasting on the given data frame using specified window size. Here, df is none other than our merge data frame, and window size is the rolling window used for training the model. Now here we are going to initialize some empty list for storing our results. Predictions, a list to store predicted stock prices. Actual, a list to store the actual stock prices for comparison. And dates, a list to store dates corresponding to the predictions and the actual values. Now moving on to our rolling window loop. The loop iterates through the data frame using a rolling window approach. It runs from 0 to length of the data frame minus the window size. The train df is the subset of the data used for training and consisting of the window size rows. The test df is the subset of the data used for testing, consisting of the next row after the training set. Now, preparing the training and the test data. Here, xtrain features for training set including date and close columns. Here, ytrain targets the variable for the training set which is close column. The xtest features for the test set excluding the date and close columns. The ytest targets the variable for the test set which is close column. Here we are going to store the date for the test instance for later reference. Now moving on, scaling the data. Scaler, an instance of standard scaler to standardize the features. The xtrain scale training features using fit transform, which fits the scaler on the training data and then transform it. The xtext scale test features using transform, which transforms the test data based on the previous fitted scaler. Now moving on to our model training and prediction. We are going to use model an instance of random forest register with 100 trees and a fixed random seed for reliability. Training the model. The model is trained on the scale training data. The trained model predicts the close values of the test instance. By using this approach, we can evaluate model's performance over time and understand how well it generalizes to unseen data. This method is particularly useful in time series forecasting, where the goal is to predict future values based on the past observations. Now, after running the rolling window forecast function and obtaining the predictions, actual values, and corresponding dates, the next step is to evaluate the model's performance using several metrics. We will calculate mean absolute error, root mean squared error, and squared error to assess how well our model performs. The mean absolute error measures the average magnitude of the errors in a set of predictions without considering their direction. Its average over the test sample of the absolute difference between the prediction and the actual observation where all the individual differences have equal weight. The root mean square error measures the square root of the average square difference between the prediction and the actual observation. It gives a relatively high weight to large errors. R squared measures the proportion of variance in the dependent variable that is predictable from the independent variable. It provides an indication of the goodness of fit and therefore a measure how well an unseen sample are likely to predict by the model. Now moving on, we will plot our actual and predicted values in a chart to see how our model is performing. As you can see here, the actual price and the predicted price. The actual price is the blue line color and the predicted price is the orange line. You can see here our model, how our model is performing. It is giving a very significant results As you can see in this chart, our model is performing very well to predict the stock prices. Now concluding this project shows us how we can use machine learning and natural language processing to predict the stock prices. While our model performs well, there is always a room for improvement. For future work could involve more advanced models, including and additional data sources. I hope you found this project as interesting as I did. If you have any kind of questions or suggestions, please leave them in the comments below. If you want to go through this project, I have provided my GitHub link below. You can go through that. Thanks for watching this video. See you next time.